Hello friends, today's lesson is heat and temperature. Heat. Look at the pictures given below and write H against the objects that are hot and C against those that are cold. Ice cream, cold. Coffee, hot. Ice cubes, cold. Fire, hot. The ability to do work is called energy. When a hot object and a cold object come in contact with each other, a type of energy flows from the hotter object to the colder one. This energy is called heat energy. The SI unit of heat is joule. An object becomes warm when heat energy flows into it and becomes cold when heat energy flows out of it. Sun is the natural source of heat energy on the earth. Temperature. The sun and a cup of tea are not equally hot. Similarly, snow and a glass of chilled lemonade are not equally cold. There is a difference in the degree of hotness or coldness of things mentioned above that we can sense. The degree of hotness or coldness of an object is called its temperature. The SI unit of temperature is Kelvin. Measurement of temperature. The instrument used to measure temperature is called a thermometer. A thermometer consists of the following parts. Bulb. This is part which actually touches the object whose temperature is to be measured. The bulb contains either mercury or alcohol. Let us discuss why mercury is used in thermometers. Mercury is preferred in most thermometers because it is present in liquid state over a wide range of temperatures. It is silvery gray in color, therefore it is relatively easy to observe. It does not stick to the glass in which it is enclosed. However, one drawback of using mercury is that it is very toxic. Now let us discuss why alcohol is used in thermometers. The range of temperature that can be measured using alcohol is as less as -70 degrees Celsius. Alcohol is cheaper than mercury. On the other hand, the drawback of using alcohol in thermometer is that the temperature above 78 degrees Celsius cannot be measured. Stem. It is a gas capillary tube through which the mercury or alcohol rises or falls as the object around the bulb warms or cools. Scale. The scale mark on the stem indicates the temperature of the substance. Types of thermometer. The three commonly used thermometers are clinical thermometer. A clinical thermometer is used to measure the temperature of a human body. The normal approximate temperature of a human body is 37 degrees Celsius or 98.6 degrees Fahrenheit, but it varies depending on age, activity, time of the day, environmental conditions, etc. It rises or falls under a state of illness. Any rise beyond 40 degrees Celsius or 104 degrees Fahrenheit is a medical emergency and requires immediate treatment. The capillary tube of a clinical thermometer has a kink or bend that does not allow the mercury to flow back into the bulb before the thermometer has been read. The mercury column breaks at the kink when it contracts due to a decrease in temperature. It prevents the mercury column from falling beyond this point. This is the reason why we have to shake the thermometer before taking a new reading. The jerk sends the mercury back into the bulb. While using a clinical thermometer, the following precautions should be taken. The thermometer should be washed before and after use, preferably with an antiseptic solution. It should be ensured that before use, the mercury level is below 35 degrees Celsius or 95 degrees Fahrenheit. The thermometer should be read keeping the level of mercury along the line of sight. The thermometer should be handled with care. If it hits against some hard object, it can break. The bulb of a thermometer should not be touched while taking a reading. Hold the thermometer by its glass body. Digital thermometer. Nowadays, electronic thermometers called digital thermometers are widely used for measuring temperature. These do not contain mercury. Hence, there is no risk of mercury being released on breakage. The thermometer is easier to read in this type than in conventional thermometers, as it is shown as a number on the display. Laboratory thermometer. As the name suggests, laboratory thermometers are used in the laboratories during experiments. The range of temperature that a laboratory thermometer can measure is between -10 degrees Celsius to 110 degrees Celsius. The following are some precautions to be taken while using a laboratory thermometer. Handle the thermometer with care. If it hits against some hard object, it can break. Do not hold the thermometer by the bulb while taking a reading. The thermometer should be kept upright, not tilted. The bulb should be surrounded by all sides by the substance of which the thermometer is to be measured. The bulb should not touch the surface of the container. Removing the thermometer from a boiling water bath and immediately immersing it in an ice bath may cause the thermometer to break. Temperature scales. Temperature is measured using different temperature scales. In a temperature scale, two reference temperatures are chosen. Most commonly the freezing and boiling point of water. Since the difference between those two is broken down into a certain number of divisions, each division is taken as one unit of the scale. The commonly used scales are the Celsius scale, the Fahrenheit scale, and the Kelvin scale. Celsius scale. This scale was developed by Andreas Celsius. The unit of the scale is degrees Celsius. On this scale, the division falls between the freezing point of water taken as 0 degrees Celsius and the boiling point of water taken as 100 degrees Celsius. 0 degrees Celsius is also called the lower fixed point, whereas 100 degrees Celsius is called the upper fixed point. There are 100 divisions between these 2 points. Fahrenheit scale. This scale was developed by Daniel Gabriel Fahrenheit. The unit of the scale is degrees F. On the scale, the big point of water is taken as 32 degrees Fahrenheit and the boiling point of water is taken as 212 degrees Fahrenheit. The lower fixed point is 32 degrees Fahrenheit and the upper fixed point is 212 degrees Fahrenheit. There are 180 divisions between these 2 points. Kelvin scale. This scale was invented by Lord Kelvin. The unit of the scale is K. On the scale, the freezing point of water is taken as 273 degrees Kelvin and the boiling point of water is taken as 373 degrees Kelvin. It is called the absolute scale of temperature since it is 0 degrees Kelvin is the absolute zero. That is the lowest attainable temperature in the universe. Conversion of scales. The three temperature scales, Celsius, Fahrenheit, and Kelvin, can be converted from one to the other using the following formula. Transfer of heat. Heat energy always flows from a region of higher temperature to a region of lower temperature till both attain the same temperature. This phenomenon is called transfer of heat. Heat can be transferred from one object to another by three modes: conduction, convection, and radiation. Conduction. Conduction is the transfer of heat from a hotter part to a colder part of an object due to collision of its particles without the actual movement of the particles from their position. Heat transfer through conduction occurs within solids and between solid substances that are in direct contact with each other. How well a material conducts heat depends on how close the particles are arranged. Therefore, solids are the best conductors of heat, followed by liquids. However, gases are bad conductors of heat. How does conduction occur? We know that the particles are closely packed in solids. That is, they cannot move freely and can only vibrate at their fixed positions. When a solid is heated, the particles which are in direct contact with the source of heat start vibrating faster. These fast vibrating particles collide with the neighboring slow vibrating particles and transfer heat to them, making them vibrate faster in turn, collide and transfer the heat to their neighboring particles and so on. In this way, heat is transferred from one particle to the next through collision of vibrating particles within substances. In the objects shown here, certain parts of these devices heat up easily, while certain other parts do not. Materials that conduct heat easily are called conductors. Metals are usually good conductors of heat. Materials that do not allow the conduction of heat are called insulators. For example, wood, cotton, rubber, clay, and cork. Air and water are also insulators of heat. Materials such as wool, feathers, and fur act as insulators because air is trapped inside their fibers. Practical applications of conduction. Following are some practical applications of conduction. Pans used for cooking are usually made of metals such as steel, copper, or aluminium, while their handles are made of plastic. Clothes made of fur trap air inside them, and this trap air then acts as an insulator. It prevents heat from escaping, keeping the body warm. Convection. Convection is the transfer of heat by the movement of particles. Convection is the primary mode of heat transfer in fluids. This is because the molecules are loosely arranged with space between them, which allow movement. How does convection take place? When liquids or gases are heated, the heated molecules rises up. For when water is heated in a vessel, the water at the bottom gets heated first. As hot water is lighter, it rises up. The colder and heavier water from the top of the vessels moves downwards. This process continues setting up circulating streams of hot and cold water in the vessels. This results in the heating up of the whole water. As mentioned earlier, convection also occurs in gases. An example of this is the formation of sea breeze and land breeze in coastal areas. The sun heats up the land during the day much faster than the water in the seas. Therefore, during daytime, the air above the land gets warm and rises up, and the air from over the sea flows in to take its place. This results in sea breeze. At night, the land cools down faster than the water in the sea. Hence, the air above the sea is hotter than the air above the land. The air above the sea therefore rises. The cool air above the land rushes in to take its place, forming a land breeze. Practical applications of convection. Following are some practical applications of convection. Exhaust fans in kitchens are always fitted high close to the ceiling so that they can remove the hot air that rises up. Room heaters are placed on the floor of a room. When the cool air is heated, it rises up and the cool air flows down to the floor. This results in effective heating of the entire room. The ventilators of a room are at the top of windows or the doors. This is because when the air in the rooms gets heated, it rises and passes out from the ventilators at the top. Radiation. Heat energy can travel in the form of waves. These waves do not need any medium to travel. The transfer of heat in the form of rays or waves for which a medium is not required is called radiation. If you stand outside in the sun for some time, you start feeling warm. How does the heat energy of the sun travel to the earth and reach us? It does so through radiation. Although radiation does not require any medium, it is also not obstructed by the pressure of any medium. Thus heat can radiate through air as well as water. All hot objects radiate heat. When radiation falls on an object, a part of it is absorbed and the remaining is affected. The amount of heat absorbed or reflected by an object depends on several factors such as the nature of the surface and its color. Darker colors are good absorbers while lighter colors are poor absorbers. Practical applications of radiation. Following are some practical applications of radiation. Solar heaters are designed to use the heat energy from the sun for cooking food. We prefer wearing light colored clothes in summer because light colors are poor absorbers of heat. Conversely, we prefer wearing dark colored clothes in winter. They are good absorbers of heat and thus keep us warm. Working on a thermos flask. A thermos flask maintains the temperature of the substance kept in it. That is, it keeps a hot substance hot and a cold substance cold for a long time. Let us understand how it works. The outer casing of a thermos flask is made up of plastic. Plastic, being a poor conductor of heat, acts as an insulator preventing the heat loss through conduction. Inside it is a double-walled container made of glass or stainless steel. Both the walls are polished so they are shiny. The space between the two walls is a vacuum. This prevents heat loss through convection since there are no air particles to carry out the transfer of heat. The shiny surface of the walls also prevent heat loss through radiation. Heat and temperature keywords. Heat, a form of energy that flows from hot object to a cold object. Temperature, the degree of hotness or coldness of an object. Thermometer, the instrument used to measure temperature. Conduction, the transfer of heat from a hotter part to a colder part of an object through collision of its particles. Conductors, materials that conduct heat easily. Insulators, materials that do not conduct heat. Insulator, materials that do not conduct heat. Convection, the transfer of heat with the help of actual movement of particles in a liquid medium. Radiation, the mode of heat transfer in which there is no medium required. Heat and temperature summary.